This starts lesson 9.5 part B. We're going to look at this question, example 4, and we're going to come up with the same answer as we would if we used the method in example 3. We're going to show you kind of a shortcut if you prefer to do the shortcut. But we noticed in the first example that in getting the common denominator, we basically ignored the common denominator after we had it. And we're going to do that in this next step here by asking ourselves, first of all, okay, again, what is the common denominator? And you would need a 6 in it and an n cubed. That would be the common denominator. Now, to get the common denominator, I would have to multiply, well, let's just do this. The shortcut or the alternative method as described in this table here is 6n cubed, the common denominator, will be multiplied by every piece. Now, the purpose of that is not to go ahead and multiply everything by it, actually doing it, but at this point, canceling things out. So I have the 6n cubed in every numerator, but before I multiply it through, I'm going to cancel the denominators out. So 6n canceled with 6n cubed, leaving you with just n squared. The n cubed cancels here, cancels there, and you're left with just 6. N cubed there, left with just 6. All right, so again, the first one was n cubed. I divided by an n, so I'm left with just n squared. So what's left is we have an n squared on top. The denominator, notice, is now gone. So I have an n squared minus the 6, because 6 times 1 is 6, equals 6 times the parentheses. I kind of skipped a step there. I have to take 6 times this whole numerator. So 6 times n, 6 times negative 1, and that's where this comes from. So it's like doing what I did before, except just a little bit of different approach and twist. Okay, so if you notice on the one over here on the left, the common denominator was 6n squared. If I would have multiplied this by 6n squared, my 3 would have canceled with the 6 and left me with 2. My n would have canceled with one of those n's and left me with just an n. And that is indeed what I got. It's up to you to decide which method you want. But again, I want to show you both so you can have a choice. Now, if I have done this second approach that I'm talking about here and I've canceled out the denominators, again, I've done the same thing. I'm ignoring the denominators in the first case. The second case, I actually canceled it out. But once I have this focus on the numerator, or what's left in this case, I would go ahead, since I have an n squared, I want to get everything on one side. So I'm going to subtract the 6n from both sides. I'm going to add 6 to both sides to get 0 on that right side, which leaves me with n squared minus 6n when I combine like terms. Now this is quadratic. I could use the quadratic formula to get this, but if you notice, I actually can just factor. If I factor out an n, I have this situation. And we've had this before. This is something that we can actually solve. What would cause this to be 0? Well, you would take this one and say 0 is a solution, and in here, this one is a positive 6. So 2 solutions, okay? But we have to always ask ourselves, are any of these answers considered excluded values? Well, if I plug a 0 in, I'll get a denominator of 0 that causes it to be undefined. So we can't use 0. So 0 is called an extraneous solution, as described above. So when you have an equation, the excluded value takes on another term. It's called an extraneous solution if it happens to be one of your possible solutions. All right. Now I'm going to skip example 5 because it gets pretty algebraically messy. I'm going to go below and do a different one. This is enough for right now. Now I'm going to approach this in my way. Okay, it's up to you which one you want to do it. But the first step is always the same. What's the common denominator? And before I can do that, I have to factor. And I'm only going to focus on the denominators when I factor. v plus 8 is factored, it's done, v is done, but I can take a v out of the last one, and I get v plus 8. Now when it's in factored form, I can look clearly at this and say, what is the common denominator? Just like before, when I had numbers being multiplied, and I had 6n, n's cubed, n cubed, or 3n, 2n squared, and so on, I'm approaching it the same way. I'm saying, what do all the denominators have? Well, this one has a v plus 8. That's one thing. This one has a v. That's one thing. This one has a v and a v plus 8. Two things. What's the common denominator? Well, the common denominator will have to have a v, and it will have to have a v plus 8. That's the common denominator. So, what will this equation need to have the common denominator of v plus 8? And that would be a v. So now I'm going to kind of do a hybrid of the last two steps here to see if it makes sense. This one needs a v plus 8. And that is a binomial, by the way. Okay, keeping that straight. This last piece has everything. It has everything, so it does not need to be changed. But at this point now, I'm going to ignore the denominators. I'm going to just go ahead and write out my new statement here. Now the first one is going to be v times parentheses 2v minus 10 minus, I'm going to write v plus 8 times v plus 3 equals v squared. That one didn't have to change at all, so v squared plus 2v minus 35. All right, that's, now I have multiplied everything on the top because I needed to do those things to get a common denominator. But notice I'm not actually doing this part because I'm going to ignore it anyway. All right, so now we distribute. So I get 2v squared minus 10v minus, now here's something we should do first. I would say minus, and then I'm going to FOIL this. First times first is v squared, because it's a binomial times a binomial, v squared, and then I'll do outside, which is a plus 3v, inside, which is a plus 8v, and then last, 8 times 3, so plus 24, equals, again, v squared plus 3v minus 35. All right, so notice that I have parentheses there. I have like terms in there. So I'm going to do this. Now I'm actually going to clean this up. What's 3v plus 8v? That is 11v. I clean that up. Now I have this negative outside the parentheses. So I'm going to distribute that. So if I distribute that, and I'm going to get rid of the parentheses, then I get a negative v squared, a negative 11v, and a minus or a negative 24. And I can get rid of my parentheses. Okay, so let's start combining like terms. We've got a lot to do here. We have a 2v squared minus a v squared, so I end up with just v squared. I have a minus 10v minus 11v, so that's a minus 21v minus 24 equals the right side of the equation. All right, so I'm going to subtract v from both sides, or excuse me, subtract v squared from both sides. So I'm subtracting v squared both sides. Now notice if I do that, my v squareds cancel. That's important because now I have negative 21v minus 24 equals 3v minus 35. Now I can solve this for v. So I'm going to subtract 3v. Oh, I made a mistake here, didn't I? It should have been a 2 all along. Why didn't you tell me? See, I go too fast. The original equation has a 2v there, not a 3. Easily fixed, okay? That's a 2. So I'm going to subtract a 2v from both sides. And in doing so, now I have a negative 23v minus 24 equals negative 35. Okay, so we add 24 to both sides. And that will give us a negative 23v equals, I believe, negative 11. Divide both sides by negative 23. And put in the division sign here. That gives us v equals, right, it's a lot there, but it's algebra, a positive 11/23. Now, is that an excluded value? Well, up in the original equation, the excluded values were negative 8, we didn't get that, and 0. Those are the two numbers we were not allowed to get. If we did get them, they'd be considered extraneous. So this works. Now again, that's a lot of algebra, a lot of multiplication, a lot of distribution, a lot of little things that we have to be good at. Okay. Now the difference between this one and the one from the previous page, or actually this one, is that there's just a lot more work because you're talking about distributing. So let's talk about this one real quick. More work. What's that mean? Well, I have to factor this first. If I factor it, this is going to be a b, then a b plus 6. This one's a b and a b plus 1. Okay. This one's over 1. All right, so the common denominator will need to have a b in it. That's what I just wrote. Okay, I have to have a b in it, a b plus 6 in it, and a b plus 1 in it. Those are all separate things. If that's the case, then on this one, I will still need a b plus 1. Right, that's what's missing if I needed a common denominator. This one has everything but the b plus 6. And this one needs everything. The b plus 6, and a b plus 1. So if you just look at one single thing here, you have a trinomial being multiplied by a binomial. That's a pretty big calculation. So I'm going to pause it, type that in so I can show you a lot quicker. All right, so let's take a look at this one. Now, I have a binomial times a trinomial, so I wrote it out here. B plus 6 times 1 is just b plus 6. And then I have a monomial times 2 binomials. So this is what I start with. So if I distribute, this is what I get. Okay, now what am I doing? I took b times b squared, got b cubed. B times 6b, 6b squared. B times negative 16, negative 16b. And then I took 1 times b squared, 1 times 6b, 1 times negative 16, and that's this piece. Now the right side, and then I have the b plus 6 still sitting there. And then on the right side, I went ahead and FOILed this, first times first, outside, inside, last. But I still have the b there. Okay, so I combine like terms. That's what I did right here. I combined these like terms and got this. I combine like terms here. I have b cubed. I have 6b squared b squared. Those two went together to get that. I have negative 16b, a positive 6b, and a b, all together to give you negative 9b. Then I had negative 16, 6. A lot of combining like terms on the left side, on the right side just a little bit. So now I have to distribute on the right side to get rid of parentheses. And I distribute the b and I get that. So now I have everything combined, all the like terms combined on both sides. So now it's a matter of just going from there and bringing things to the left side. So if I bring the b cubed to the left side, they cancel. If I bring the 7b squared to the left side, they cancel. And we're left with that. And I go ahead and combine like terms. I bring the 6b over to here by subtraction, and I divide by negative 15, and then I get b equal to a negative 2/3. It's not an excluded value, so that's considered okay. All right, now I'm going to stop there. I know I have one more left, but I think what we'll do is we'll save that one for class if everyone has questions. This ends part B for 9.5.